Good morning. I am going to assume that you've all done Pythagoras theorem before. Okay, so today's video is about Pythagoras and it's a lead into trigonometry, but I'm going to assume this is something you've done before. Now, if you're scratching your head thinking, what on earth are you talking about? Look on class charts. I've put a link to a more basic video. It's not one of mine, it's from a site called Corbett Maths, where he goes back a little bit further and goes into a bit more detail about how Pythagoras works. But I'm just going to go through the basics of it very quickly, and then you've got a set of questions attached that I'd like you to try, and that's that's Friday's lesson done. So Pythagoras' theorem is all about the lengths of right-angled triangles. If this angle here is fixed, then if you make that side longer, it affects the lengths of the other sides. And it was actually the Egyptians that first realized that the sides of a right-angled triangle were related. But it was Pythagoras, a Greek mathematician, who was the first one to sort of formally set it out. And he was a bit of a funny bloke, Pythagoras. He was a bit of a cult leader, lived on an island with all his followers. They murdered him eventually. There you go, there's lovely. But his sort of legacy to the world is this theorem, which is named after him. And we basically have two sorts of problems with Pythagoras. We have problems where we're given a right-angled triangle, we know the length of the two shorter sides, and we want to work out the length of the longest side. The longest side in a right-angled triangle has a special name. It's called the hypotenuse, and it's easy to spot. Okay, it's the longest side, but it's always the side opposite the right angle. It's the side that you get if you go from the right angle out. It's this side opposite. So in this problem, we are finding the length of the longest side. And there are two ways you can set it out. You can set it out on the diagram, which is sort of my favourite way, or you can set it out using sort of algebra, and I'll do both ways. So let's do the diagram. So what you do with Pythagoras' theorem is you say, right, I know these two shorter sides, I'm going to square those two lengths. So 8 squared is 64. I put it in a square to remind me that that's what I've done. I've squared it, I've multiplied it by itself. And 5 squared is 25. And Pythagoras realised that if you added those two square numbers together, you got the square of the longest side. So that is 89. So this side isn't 89 centimetres long. That's the square of the length. And so if I know the square of something and I want to work out the length itself, then I have to do the inverse operation. I have to do the square root. So if you're not familiar with the square root sign on your calculator, hopefully you can find it. But the square root of 89 gives me 9.4338. So I'm going to round to 1 decimal place. So my missing length is 9.4 centimetres. And I like to set problems out like that because it's sort of graphical. However, I realise that in an exam we ought to show a little bit of method. So what we're saying is that to work out x, the missing length, I took 8 and squared it, and I took 5 and squared it. I added those two squares together to get 89, and then I square rooted the answer. So that's how I would set that out in an exam. I do the diagram as well, but that's how I'd set it out. So if you want to find the longest side in a right-angled triangle, square the two sides that you know, add those two squares together, square root that, and that gives you the length of the longest side. Second sort of problem then. What about if you already know the longest side? Look, right angle, opposite the right angle, I already know the longest side. I want to work out one of the shorter sides. Well, we do Pythagoras in reverse. I know that that number squared, 20 squared is 400, plus this number squared, don't know this number, must add up to make the longest side squared. And this time I know the length of the longest side is 42. So 42 squared is 1764. So this plus this give me this. So we just work backwards. This, take away this, give me this. And so the length of x is the square root of that number. So I'm using the square root again, 1364, and I'm going to go over one decimal place again. And in this problem we were dealing with meters. So if I wanted to set it out properly, well, okay, here we go. So to work out x, I took the longest side squared, I subtracted the one of the shorter sides squared, and I square rooted that. Actually, I could even be, if I do it like I did over here, I could even write it like this, couldn't I? So that is 42 squared, and that's taking away 20 squared. So my answer is... So the first thing you've got to do whenever you're faced with a Pythagoras question with a right-angled triangle is you've got to ask, is it this? Am I being asked to find the longest side? Or is it this? Am I being asked to find one of the shorter sides? If I'm being asked to find the longest side, then I'm adding the two squares together. If I'm being asked to find one of the shorter sides, then I do the longer square, take away the shorter square. Don't forget at the end you always need to square root to get your actual answer. Now the sheet I've attached includes some basic practice like those two last examples, but we need to try and get a bit harder, a bit quicker, because this is definitely something we've done before. So here's what I call a two-step problem. In this diagram I have two right-angled triangles, and I'm being asked to find the missing side in one of those triangles. But I don't know two sides in that triangle. So in this case, I've got to use the first triangle to work out the length of the hypotenuse. So I'll label that length h. And then once I know that, I can ignore the first triangle and use Pythagoras in that triangle. So let's ignore this top triangle and just use Pythagoras to work out this length here. So in the first triangle, am I working out the longest side or one of the shorter sides? Hopefully you can see it's the longest side. So I'm going to square the two lengths that I know, 7 squared, 12 squared. I'm going to add those two squares together. So that gives me 193. So h is the square root of 193. h is equal to, I did 7 squared plus 12 squared, which gives me the square root of 193. I'm not going to bother working that out. Let me explain why. If we now ignore that triangle and we now just look at this triangle, I'm going to turn it so I can see it sort of in a normal... There we go. So I'm ignoring this triangle down here. I'm now just looking at this triangle. I'm trying to work out this side here. Is this side the longest side or one of the shorter sides? Hopefully you can see it's one of the shorter sides. So I know that I need to work out the longest side squared, take away this side squared, is going to give me this side squared. So 15 squared, that's 225. This side squared, well, I know it's 193. I never actually bothered working out the actual length. I never bothered square rooting it because I knew that when I came to this triangle, the first thing I'd have to do was to square it again. So I've just left it as 193. So this side squared is 225, take away 193. So x is equal to the square root of 32, which again isn't going to be a nice round number. So x is going to equal it's 5.656, so that's 5.7 centimetres. Now I ought to do a little bit of working there, so let's go back to this way round. So I've already done a bit of method here to show how I got h. So now I'm going to say, okay, to work out x, I took 15 and squared it, and I subtracted this side squared. Well, I never actually worked out that length, but I know that side squared is 193. I did that, take away that, which gave me 32, and then I square rooted the answer. And that was 5.7 centimetres. So that's a two-step problem where you work out a missing length in one triangle, and then that new length, that answer, is used in a second triangle. And normally you can avoid having to square root it, because the first thing you'll do in the second triangle is square it again. And then the last sort of problem that you come across is one of my favourite games, and that is, where's the right angled triangle? Here we've got an isosceles triangle. Pythagoras doesn't work in isosceles triangles. It only works in right angled triangles. And we're asked to find the height of this triangle. This doesn't appear to be a Pythagoras problem at all. We're being asked to find that dimension there. Oh, hang on a minute. I can see two right angled triangles now. I can see one here, and because it's an isosceles triangle, they're both the same. So what I'm being asked to do, if I take that and just draw half of it, that's the side I'm being asked to find. This is 8 centimetres. And this side here, well, because it's isosceles, that line's going to cut that exactly in half. I know my diagram's a bit shonky, so it hasn't worked, but there we go. Here's that question. Am I working out the longest side or one of the shorter sides? Hopefully you can see that I'm working out one of the shorter sides, so I'm going to take the longest side squared, and I'm going to take away the shorter side squared. So 64, take away 25. That doesn't tell me the length of this side, does it? That tells me the length of that side squared. And so I just need to square root 39 to get the missing answer. And I'll go with 1 decimal place. So that's 6.2 centimetres. And if I wanted to set that out with some method, to work out the missing length, I took the longest side and squared it, and then I subtracted this side squared. I know I'm subtracting because I'm working out one of the shorter sides, and then I square rooted it. So we've got basic problems where we are given a right angled triangle, excuse me, and asked to either find the longest side or one of the shorter sides. You get two-step problems where you work out a missing length in one triangle and then you use that in a second triangle. And then the most common question of all is not just ones with isosceles triangles, but ones where it's not immediately obvious where the right angled triangle is. You'll notice that in each of these questions, the word Pythagoras didn't feature. So the question said, find the height of this triangle, find x, find the missing side. You've got to realise that if there's a right angled triangle there, this is going to be a Pythagoras problem. I hope you've all got calculators, either on your phone or actual calculators, which will square and square root. Get in touch with me if you are struggling to use the square root function. And I've attached a set of questions with solutions as always, and I hope that you find that accessible. No need to submit anything, but on Monday we'll do a little bit more Pythagoras practice, and then the following Friday we'll get into trigonometry at last.